Well, here are the answers to the stunning quiz that we had today, and you may have to go through these questions many times because they are really important. And in question 1 we have the magnitudes of the forces shown in the figure. You have 3 forces and 1 angle shown. But you can understand that 2 of these forces are, one is along the y-axis, the other is along the negative x-axis, and there's only one that is inclined. So to find the resultant, the idea is to resolve this force into its 2 components. One will be along the x, the other will be along the y. So you have F1, F2 and F3. F1 is broken up into its 2 components, and that's 80 cos 30, which is 69.28, and this is 80 sin 30, which is 40 newtons. Okay, that's 69 newtons now. So you have F2 as 60, and this is 40.0. So for F3 is 40.0. Now consider the total x component. You have 69.3 to the right and minus 40 to the left. So that is 29.3 to the right. And net force along the y, you have 60 positive and 40 negative, so 60 minus 40, that is 20 newtons. And so to find the net of these, once you have the x and the y, you square both, add them and take the square root, and you will get the resultant force, which is 35.5 newtons. And to find the angle, always take tan theta is equal to Fy by Fx, because Fy is going to be the opposite side and Fx is the adjacent side of the right angle triangle, which I have not drawn. So that's how you get the magnitude of the force and the angle of the net force. In the second question, you have 2 vectors, A and B, and you have to find which of these 4 or 5 is the vector C given by 3A minus B. So what you have to do is you multiply vector A with 3, because it's 3A, and subtract B from there. Okay? Vector A is 2I plus 2J, and vector B is 3I plus 4J. Let me speed that up. And C is given as 3A minus B. So that's 3 times all of vector A, which I've written now, minus vector B. And this is just scalar multiplication, so 6, again 6 sine, 6j, distribute the negative sign, so both will become negative, right? Because negative times positive is negative. And now you have 6i minus 3i, which is 3i. 6j minus 4j is 2j, and that's the answer. On the third one, a rock is thrown at a window that's located 18 meters above the ground. The rock is thrown at an angle of 40 degrees above the horizontal and is released from a height of 2 meters above the ground with a speed of 30 meters per second. If the rock strikes the window on its upward trajectory, from what horizontal distance from the window was it released? Good question. Need the diagram. somebody picking up a rock and throwing it, and that is 18 meters is the height of the window, and person is projecting it at an angle of 40 degrees above the horizontal. All that is in the question, giving it a velocity of 30 meters per second, and from a height 2 meters above the ground. So you have the 2 meters above the ground. This is not drawn to scale, of course, no. Okay, but just to give you an idea, yeah, not at all drawn to scale. Now that is 40 degrees. Now delta y is 18 minus 2. Because it starts from here and reaches here, that's 18 minus 2, 16. A is negative because it's going up. We're trying to find the time, and we know that VOY is 30 sine 40 degrees, which is 19.3 meter per second. All right. That's because you break this up into vertical component VOY and horizontal component VOX. And then VOY would be 30 sine 40, right? That is why I've written it here. And then the equation is the king, which is delta y, is V naught t plus 1/2 AT squared. And the plus becomes minus because A is negative 9.8. Rearrange that, you get a quadratic equation. The solution of this quadratic equation is minus b plus or minus square root b squared minus 4ac by 2a. Okay, it's minus b, that's why it's plus 19.3, because b is minus. Okay, b squared minus 4ac by 2 times 4.9, which is 2a. You get 1.2 seconds. So it takes 1.2 seconds to get there, and what we got to find is the horizontal distance. We know that the horizontal component will never change. It's a constant, and in this case it is 30 cos 40. So delta x is just V naught x multiplied by t. So it's 30 cos 40 multiplied by the time, which is 1.2, which will give us the answer as 27.6 meter. That is the distance, the horizontal distance from which the rock was thrown. Number 4, vector m is 4 meter and points eastward. Vector n, 3 meter, points westward. The resultant vector m plus n. Okay, those are the two vectors. One pointing to the east, the other pointing to the west, right? And the resultant is actually 4 plus minus 3. Why is it minus? Because it's along the negative x-axis. So that is 1 meter to the east. That's all there is to it. That's such an easy question. Number 5, a hockey puck slides off the edge of a table with an initial velocity of 20 meters per second. So that means that is a horizontal velocity, because a table is usually horizontal. And the height of the table above the ground is 2 meters. What is the angle below the horizontal of the velocity of the puck just before it hits the ground? All right. So what's the initial vertical velocity of this puck? Initial vertical velocity is 0 because it's projected horizontally. So that's the diagram. It's the horizontal velocity. That is the vertical height. Do not mix up the two. We got to find that angle, theta. Now we do know that the horizontal velocity never changes. So from the moment it's projected to right before it hits the ground, all the way, that horizontal component never changes, so it's 20 meters per second. But the initial vertical component was 0, there was nothing. But as it moves on, there is an acceleration, and just before it hits, we do have a vertical component, which we're going to find out. That is VFY. We know the initial is 0. So use this equation. That whole term becomes 0. And from there we can figure out the time. 2 delta y by A. Delta y is 2, A is 9.8, and you get 0.639 seconds. 0.639 seconds. Now we can find VFY using VOY plus 80. 9.8 times 0.639. That gives 6.26 meter per second. So now we have the horizontal velocity just before hitting it, and we also have the vertical. And from that right triangle, tan theta is Vy, which is the same thing, divided by Vx. So you get theta as 17.4 degrees. And that is the problem. Number 6, a child throws a ball with an initial speed of 8 meters per second at an angle of 40 degrees above the horizontal. The ball leaves her hand 1 meter above the ground. At what angle below the horizontal does the ball approach the ground? Let's get the diagram. 8 meters per second, 40 degrees. So the components are 8 cos 40 and 8 sin 40. The horizontal component is 6.13, never changes. The vertical initially is 5.14, and delta y is -1 meter. Why -1? Because it leaves our hand 1 meter above the ground. It's going further down, so it's -1. Considering that the initial vertical velocity is up, that's why that direction is taken as positive. Anything down is taken as negative. VOY is 5.14 meter per second. A is 9.8 meter per second squared, and find VF using this equation. You get 6.78 meter per second. That's the velocity right before it hits the ground. Okay, the horizontal does not change. Now, just like in the last problem, we can find the angle theta using tan theta. Tan theta is now 6.78 divided by 6.13. And you get 48 degrees as the answer. Number 7, you have a vector A, 6 meter points, 30 degrees north of east. Vector B, 4 meter points, 30 degrees south of west. What's the resultant? Here's the diagram, the two vectors. One north of east, the other south of west. Okay? Break them into their components. That's along the east, that's the west. That is 30 degrees. Both angles are 30 degrees. And so what's A plus B? Is 6 plus -4. You know, this is easy because they're exactly opposite to each other. So all you got to do is 6 minus 4, 2. And what would be the direction? This is a bigger vector, so it will be north of east at 30 degrees. Such an easy question. Eighth one. Again, vector A has magnitude 5, points in a direction 40 degrees counterclockwise from the positive x-axis. What are the x and y components of vector A? All right, so that is the x-axis. That's going counterclockwise. So going counterclockwise by how many degrees? That's 40 degrees. So that is your vector. And just break it up into its components. It'll be 5 cos 40 and 5 sine 40. Those are the components. AX and AY. So AX is 3.83 and AY is 3.21. Number 9, it's similar. It's same question as before, only what you got to find is different. All right, the hockey puck sliding off the edge of a table. Remember that question? Here it says, what is the magnitude of the vertical component of the velocity just before it hits the ground? And we did this. We did this yet again. I'm writing it. We just need to find the vertical component. Initial vertical component is 0. Since the initial vertical component is 0, and you got to find the final, remember what we did? We found, I'll let this roll by, we found the time as 0.639 and then use this equation to find the vertical component. We had done this before, so that's the answer. Number 10, a ball is thrown at 60 degrees above the horizontal across a level ground. It is released from a height of 2 meters above the ground with a speed of 18 meters per second. How long does the ball remain in the air before striking the ground? Okay, this is the situation. You throw the ball from here, and therefore delta y is minus 2 meters. So because it goes below where it was thrown. And of course, the components are 18 cos 60 and 18 sine 60. And to find the time, you only take the vertical component. So the initial is 15.6. A is minus 9.8 meters per second squared. We're trying to find the time. Delta y is minus 2 meters because it goes below where it was thrown from. And use this equation. Rearrange it to get that quadratic again. That's A, B, C there, right there. Use the quadratic formula. You get 3.30 seconds. That's how long the ball remains in the air before striking the ground. And 11. A child throws a ball, initial speed of 8 meters per second at an angle of 40 degrees. Above the horizontal, the ball leaves her hand. We've done this question before. 1 meter above the ground. How long is the ball in flight before it hits the ground? So I just want you to refer back to question 6 because we had done it. Now we had actually calculated it, but I'm just reminding you the final velocity we got 6.78. Excuse me. The initial is 5.14. A is 9.8 minus 9.8, and we're looking for time. The final is negative because it's downwards, while the initial is upwards. Okay. Rearrange to make time the subject. (1.22 seconds). Brings us to the 12th one. Okay, here we have a little bit of calculus. You have the velocity given by this vector, okay, and acceleration, and if the object is located at this position at time 0 seconds, what is the position after 1 second? You got to find position. All right. Remember that velocity is the integral of acceleration with time plus the constant of integration, which is the initial velocity. In this case, the acceleration is 2, isn't it? 2 2ti plus t squared j. That's what is given. And that is the initial velocity. When you integrate that, you get 2t squared by 2 plus t cubed by 3. And then if you integrate the velocity again with t plus the initial position, you get the displacement. So that's the displacement. When you integrate that, you get t squared. This term is t cubed by, now actually it's 2 and 2 cancel, that's t squared. When you integrate, you're going to get t cubed by 3. This becomes t raised to 4 by 12. And at t is equal to 1 second, you see that when it's 1 second, these two will cancel out, and you add the i's, you get 4.33i plus 0.08333j. So that's what you get. 13. A projectile is launched from the ground level at an angle of 50 degrees above the horizontal with a speed of 30 meters per second. Projectile is moving over level ground. How far away from the launch position does it contact the ground? Figure. There it goes. 50 degrees, 30 meters per second. Break it up into its components. And that's delta x. Delta x is, I'm using the ready-made formula now. VO squared sine 2 theta by g. Remember that this formula only works when it goes from ground to ground. The other way of doing this problem was to use the initial vertical component to find the time. After you get the time, multiply that with the horizontal component. You will still get the same answer. And that is 14. The last one, vector A has components. AX is 12 meter, AY is 5 meter. What is the angle that vector A makes with the x-axis? That's so simple. AX and AY both given. That's the right angle triangle. This is the angle you're looking for. Definitely tan theta is AY by AX. You've given both the values. 5 by 12, find that whatever that is and take the inverse of that. You would get the angle as 22.6 degrees, and I'm so glad that I could get through with this. And I hope you look at this and understand it for the exam. Goodbye.